We're going to simplify some more expressions here. This time they have rational exponents. You have to be very careful. It's very easy to make a mistake. You have to concentrate on what you're doing. And there's multiple ways to do any of these. I'll show one, maybe two, depending on the problem. This would be 5 squared. That's 25. And what we could do is immediately deal with this negative 1/3 times negative 3/2. So we have a negative times a negative is a positive. The 3's reduced, so we're left with 1/2. And we get 5 to the first power. On the next one, 27 is 3 cubed. 8 is 2 cubed. Raised to the 1/3. Now this 1/3, we're going to have 3 times a third, and we get 1, and that's also going to apply to the exponent of 3 on the bottom. So we get 3 over 2. This one's a little harder since it has a negative sign in it. But remember what that negative means. We're going to flip what's being raised to the power, so we can have it as 8 over 27. And then we change this negative to a positive, so it's to the 2/3. Similar to the last problem, we'd have 2 cubed over 3 cubed. This time when we multiply the exponents, 3 times 2/3, we get 2. So it's 2 squared, and similarly on the bottom, it's 3 squared, and we get 4/9. The next one is a little more involved. There's several things going on. So let's first flip the fraction. 8 over 27 raised to the positive 1.5, which is the same as 3/2 power. Do the similar. I'm going to need a little bit more space here, so it'll come out a little bit. And this will be 2 cubed over 3 cubed raised to the 3/2. This time it doesn't simplify nicely as the previous problem. And so this will be 2 to the 9/2 over 3 to the 9/2. Now we need to realize how to simplify that. That's the same thing as saying 2 to the 4.5 over 3 to the 4.5. Now what is 4.5? That's the same as 4 plus a half. And this can be written as 2 to the 4th. And if we think of plus 4.5, or plus a half, and then 3 to the 4 plus a half, this is 2 to the 4th times 2 to the 1/2. So it's basically taking our rules and going backwards, because what we're doing here is simplifying over 3 to the 4th times 3 to the 1/2. And this gives us 16, and the half is the same as the square root over 81 times the square root of 3. Now we'll rationalize this by multiplying by root 3 over root 3. And so get 16 square root of 6 over 81 times 3, which is 243. Another way to have simplified 2 to the 9/2 is as follows. You could say that is 2 to the 9th raised to the 1/2. And 2 to the 9th is 2 times 2, 9 times. So there's 4, 5, 6, 7, 8, 9. And we're taking the square root of that. The square root of 2 times 2 is 2. Here's another 2, and another 2, another 2, and we're left with 1, 2 still inside. And what does that give us? That gives us 16 root 2, and that's what we got up here by doing it, simplifying using the powers. So what's the idea that I'm going to use here is I'd want to get a whole number so I could use that, and that's outside the radical, and then whatever's left inside. Here's a review of radicals. X to the 4/3 can be written as x to the 4th to the 1/3, and 1/3 is a cube root, so it's a cube root of x to the 4th. Over here we have cube root of 4 times the cube root of x squared, and so we'll get the cube root of 4x squared. Now on this one, if you notice the difference between them, we're trying to write it with one radical. These have the same roots. If I did this one, this is a 10th root of x times 1 over the 5th root of y. Well, those aren't the same radicals. They're not the same root, so I can't combine these into one right now. What could I do? What determines what root it is? That's the denominator number. So if I take this, I can rewrite this as x to the 1/10 times y to the what over 10? Be -2. So this would be the 10th root of x times the 10th root, 1 over the 10th root of y squared, and we'll be left with the 10th root of x over y squared. In general, x to the 1 over n will equal the nth root of x. And I have x to the a over b. This can be written as a couple of different ways. You could write it as the bth root of x to the a, or, I'll make sure that's completely inside, or you could write it as the bth root of x all raised to the power of a. Now, when will this expression give an imaginary number? Well, we know an imaginary number, if you think back, an imaginary number would be something like square root of -4. So we know we have to have a negative number inside, so x is going to have to be less than 0. Now, if we raise x to the power of a, what does a have to be in order for this to still be a negative number? A would have to be odd. What root is this? This is a square root. Even though it's not written, there's an implied 2 there. And so what does b have to be in general? B has to be even. The purpose of 8, 9, and 10 is to say that we have to pay attention to details here and write things correctly. So this is telling us 16 is 4 squared raised to the 3/2. 2 times 3/2 is 3. So that gives us 4 times 4 times 4, which is 64. Over here, how does this a negative affect it? This says negative of 4 squared. What's being raised to the 3/2? Only 16. So it's similar to what we just had, but it's -64. And how does it change it if you have a negative inside being raised to the 3/2? Well, remember we could go as -16 to the 3rd square root of it, or we could do square root of -16 raised to the 3rd. Which one of those would be easier? I think the second one, because we can say square root of -16 is 4i raised to the 3rd, which would give us 64i cubed. And what is I cubed? Remember that I is I squared is -1, I cubed is -I, and I to the 4th is 1. And then it repeats. So this is 64 times -I, or -64i. Right, using only positive exponents and no radicals. This is basically just a skill problem, working on these exponents and trying to write them. We have 27. A to the -1 is the same as 1 over a to the 1st times b squared. All of that is being raised to the, it's a 6th root, so that's a 1/6 power, and then that is all being raised to the 4th. Now we have 1/4, or 1/6 times 4 will give us 2/3. And we have 27, and since I'm dealing with exponents, I'm just going to write that as 3 cubed. 27 is on the top, a is on the bottom, b squared is on the top. Now we can apply our exponents. 3 cubed, and then 3 times 2/3 would give me 2. So this would be 3 squared. And then 2 times 2/3 would be 4/3. A to the 2/3. And that can be written as 9b to the 4/3 over a to the 2/3. Let me put my equal there. All right, let's go to number 12. So we have, this time we're going to be solving equations. Make that a little bit bigger. Now we have two exponentials are equal and their bases are the same, so therefore their exponents or their indices must be the same. So for x equals 12, x equals 3. That's a pretty basic one. This one's a little bit different. We now have a base of 9 and a base of 3, but we'd want the bases to be the same. So we're going to make this one, we can write both as a power of 3. So it's 3 to the 2x equals 3 to the 8. So we get 2x equals 8, x equals 4. And the last one, what could we write both 8 and 16 as a base of? A base of 2. So this is 2 to the 4x equals 2 to the third. The bases are the same. 4x equals 3, x equals 3/4. Now we start getting in a little bit more, a little different. We have 81 and 1 over 27. 81 is 3 to the 4th power. And that's being raised to the 2x plus 1. And then 27 is 3 cubed, so 1 over 27 would be 3 to the negative 3. And that's being raised to the 2 minus x. Now we can apply our exponent rules. This is an exponential to a power, so we're saying 3 to the 8x plus 4, multiply those out, and 3 to the negative 6 plus 3x. We now have bases the same. I always want you to make sure that before you set the exponents equal, you have one base on each side. So you get 8x plus 4 equals negative 6 plus 3x. Move the x's to one side. We have 5x equals negative 10. So x equals negative 2. Over here, we're looking at 9, 3, and 27. Say, oh, they can all be written as a base of 2. So this would be, or a base of 3, sorry. 3 to the 2x equals 3 cubed times 3 to the 3rd raised to the 4th. So we have 3 cubed times 3 to the 12th. Now note, some people want to stop here and try to do it. Like I said in the previous problem, I want to see one base on each side. So I get 2x equals 15 now. I have one base of 3. I set the exponents equal, so x equals 15 halves. All right, 17 to 20. Now we're dealing with negative exponents, and this one, they're going to be a little bit harder, but not too bad. We just have to apply what we know. Here we have 3 times x to the negative 2. Only negative 2 is being raised to that power, or x is being raised to the power of negative 2. So let's get rid of the coefficient 3 by dividing both sides. We have x to the negative 2 equals 81 divided by 3, which would be 27. Now, there's a couple ways we can go about doing this. One of them is just to say x to the negative 2 is the same as 1 over x squared equals 27. Now, we've done this before, but just to remind you, if you have two fractions are equal, their reciprocals are equal as long as they're not 0. So we get x squared is 1 over 27. And now we can take the square root of both sides. We have our plus or minus. X equals plus or minus 1 over. We need to simplify that. That's 9 times 3. And the square root of 9 would be 3. So this is 3 root 3. And we'll rationalize this again. Multiply by root 3 over root 3. So we get plus or minus square root of 3 over 9. Very similar again to 17, except 3x is being raised to the negative 2. So we could treat it the exact same way as 17, or what we could do, and I'll show you just to have something a little bit different. Since the whole thing's being raised there, let's raise it all to the negative 1/2 power. Now what you have to be very careful about that, and this can be harder for many people, is to realize that this 1/2 is actually a square root. And so we have a plus or minus has to be added in there. The benefit of this, we get 3x equals plus or minus, And I'll start simplifying this. 9 squared to the negative 1/2. So we'll get 3x equals plus or minus 9 to the negative 1. And that's the same thing as 1 over 9. We get 3x equals, so x is going to equal, divide both sides by 3, plus or minus 1 over 27. And that one's done. Now, it doesn't matter to me which method you want to use. We could treat that same thing on this problem. And I think fewer people will make mistakes using the first one, but it's up to you. This time we have a coefficient and some stuff raised to the negative 2, so I'm going to get rid of the coefficient first. So I have x minus 3 to the negative 2 equals 16. If I did it as the first method, it'd be 1 over the quantity x minus 3 squared equals 16. So again, two fractions are equal, their reciprocals are equal. So x minus 3 squared equals 1 over 16. We can take the square root, add our plus or minus. X minus 3 squared, x minus 3 quantity squared equals plus or minus 1/4. Oh, I put that squared back on. No, it's gone there. And so now x equals 3 plus or minus 1/4. So 3 plus 1/4 would be 3 1/4, and 3 minus 1/4 would be 2 3/4. Now let's take a look at some of this couple word problems here. I have to zoom out a little bit. Now, when we look at this, it says the value of a computer depreciates at a rate of 25% per year. If it's worth $2,400 now, find its approximate value 3 years, 6 months from now, and 20 months from now. Give me a couple minutes. So what's different about this compared to what we did on the last set of notes is we have a part of a year, not a complete year. Now, what did we do before? We have our initial value, which is our 2,400. We're going to say 1. Now it's depreciating, it's decreasing, it's going down by a rate of 25%. So we're subtracting our 25%, and we are going to raise that to a power of t. This is what a of t will be. So now a of 6 months is how much of a year? It's half a year. So we have 3.5 equals 2,400 times 0.75 raised to the 3.5. Now you can take out your calculator to plug that in, and you will get, you should do this just to make sure that you're getting the right number, $876.85. Now, really this is too accurate of a number given that this is 2,400, but the main thing I want to work on is this part. I'm not as focused with this answer. Now 20 months ago, what we have to do is we have to convert the months into years. So 20 months times 1 year, which is 12 months. The months reduce, and we're left with 20 over 12 years, which is 4 goes into 25 times and then 12 3 times. So that's what our time is this time. Now it said 20 months ago, so that's going to be, going forward would be a positive number, going in the past would be a negative number. So this is going to be negative 5/3. And I just plug it in, 2,400, 0.75 to the negative 5/3. Make sure that when you type in negative 5/3 on your calculator, you have a parentheses around that. Go ahead and do that, and this gives $3,876.52. And then the last one is my last year of school 20 years ago cost $13,500. It cost $24,000 $100,000 per year now, what was the annual rate of increase? So let's set this what up. Just dealing with this part, we have 13,000 would be our initial amount of money. And then we don't know what the rate of increase was, so we're going to have to say 1. We know it's going up, so the rate it would be R, and R is written as a decimal, so we'll put it over 100. And it was over 20 years, so we'll put that to a 20, and we're going to set this equal to 24,000. Now it shouldn't be 24,000, it's more like 34,000 nowadays, but so now let's take this and we're going to divide both sides by 13,500 because our goal here is to solve for R. So take 24,000 divide it by 13,500 and you get 1.77 with a bar on it equals 1 plus R over 100 to the 20th. Now, what if I had a number like 1.7 equals something squared? What would you do? You would take the square root of it. Well, since it's raised to the 20th, what we want to do is raise it to the 20th root, or 1/20th power. So take that and then raise it to the, make sure you have your parentheses around 1/20th, and you get 1.029186 blah 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 equals 1 plus R over 100. Subtract the 1, 0.0291686 equals R over 100. Multiply both sides by 100, and we'll get R is 2.9186 blah blah blah. So if I told you to round to the nearest 10th place for this, this is now our percentage. The nearest 10th, you would look at the final answer here and then round this to the 10th to say 2.9%. So the annual rate of increase is approximately 2.9%. If I told you to round to the nearest 100th place, you wouldn't go at this stage. You would have to go after you've actually found the interest rate. And that's it for this set.